Well, next we're going to discuss a very common oxidizing agent, which is halogen. Okay, so once again, we try to have a quick revision on what is meant by oxidizing agent. Now, in your notes, okay, they give you a series of half equation about the halogens. Well, all the halogen elements shown in the red color will turn into their corresponding halide ion, which is black in color. Okay. So, first of all, we want to ask why the iodine is weaker oxidizing agent while the fluorine is the stronger oxidizing agent. Well, the reason behind is very simple. First of all, we need to understand the reactivity of halogen, okay? Similar to the nonmetals, the reactivity of halogen will decrease down the group. This is because after we increase the atomic size when moving down the group, okay, the power in receiving electron will also decrease. Okay, well, that means they will not undergo reduction easily, and hence that's why they become weaker oxidizing agent. Now in the second slide, we are going to have another point of view. Okay, in the past when we discussed the reactivity of an element, okay, here it comes to our conclusion is whether for the metal with higher reactivity, their compound has higher stability. Okay, so we use sodium as an example. Now everyone understands that sodium is a very reactive metal. Okay, and that means we can draw the following conclusion is the sodium compound is very stable, or we can say it is very difficult for us to decompose the sodium compound into sodium metals. Well, similar idea as move to the nonmetals. Okay, fluorine. Now this time we understand fluorine is more reactive than iodine. Well, with the same idea, that means the fluorine become fluoride ion, which is a very stable ion, and it is very difficult for fluoride ion to lose their electron and become fluorine again. So we have the following idea. From fluoride ion to fluorine is very difficult, but from iodide ion to iodine is much easier. Well, this make us move to the next page, okay? And now we understand the halide ion now this time is become a reducing agent. So in the blue sentence, okay, what is meant by reducing agent is it is a species that undergo oxidation, or you may say they lost their electron or increase in oxidation number. So in the previous slide, we have seen that the iodide ion can turn to iodine or can lose their electron easier. Well, that means that they are stronger reducing agent because they can lose their electron easier. Well, on the other hand, fluoride ion cannot lose electron easily. That means the fluoride ion is a weaker reducing agent. Okay? And the final conclusion we can draw is the reducing power of halide ion increase down the group. Okay? So let's see in the next page in your notes. Okay, we have a example in displacement reaction. Now we understand that the reactive metal can lose electron to extract less reactive metal from ions. Well, this is a very common displacement reaction you have learned. Okay, but for non-metal part, we have the similar idea, which is the reactive non-metal can gain electron to extract less reactive non-metal from ions. For example here, the chlorine gas can displace bromine from bromide solution. Okay, and in this reaction, the chlorine undergo reduction and the bromide ion undergo oxidation. Well, similarly, we can use chlorine to extract iodine from iodide, and here are the equation and the half equations. So everyone should pay attention and have a look on that. Finally, both bromine solution and iodine solution shows orange-brown color in aqueous state. So how can we distinguish them? Well, the idea is we use organic solvent, which shows different colors. And in the video below,
you can see
I can show you more.
Both of them are almost colorless. Okay.
Well, on the left hand side,
here
I have
the
bromine solution,
which is
and on the right hand side, I got iodide solution.
And see if there is any color change. Now, it looks like there is a significant color change, right? For the left-hand side, for the potassium bromide, the solution changed to yellow color. For this one, turned to orange-brown color. But this is not a significant evidence for the proof of which one is potassium bromide and which one is potassium iodide, because the darker color can be due to the higher concentration. Now, that's why we try to add some water in it. Okay, for example, this one. If I dilute the solution, okay, so you can see the color change may not as significant as we expected. That's why we need a further experiment to prove or to identify both compounds. Now, I have prepared an organic solvent, which is hexane. So let's see the color change of halogen in the organic solution. Now, you can see there is a significant change for the bromine layer in organic solution. Okay, this is orange black or orange yellow in color, while for the iodine in organic solution, it shows purple or violet color.
Finally, we have a quick look on the reaction between chlorine and sodium hydroxide solution. Well, chlorine will become chloride ion Cl- and hypochlorite ion OCl- when dissolved in water, and the solution is become from yellow-green to colorless. Here shows the equation. Now, in this equation, we can understand that, or we can notice that, first of all, one of the chlorine atom undergo oxidation to form OCl-, okay? Or the other one become chloride ion, which is Cl-. Well, that means the same species chlorine undergo oxidation and reduction at the same time, okay? And this is what we call disproportionation reaction.